A military engineering vehicle is a vehicle built for the construction work or for the transportation of combat engineers on the battlefield. These vehicles may be modified civilian equipment purpose-built in military vehicles. Types of military engineering vehicles: civilian and militarized heavy equipment. Military engineering can employ a wide variety of heavy equipment in the same or similar ways to how this equipment is used outside the military. Bulldozers, cranes, graders, excavators, dump trucks, loaders, and backhoes all see extensive use by military engineers. Military engineers may also use civilian heavy equipment which was modified for military applications. Typically, this involves adding armor for protection from battlefield hazards such as artillery, unexploded ordnance mines, and small arms fire. Often this protection is provided by armor plates and steel jackets. Some examples of armored civilian heavy equipment are the IDF Caterpillar D9, American D7 Turnpike P, Canadian D6 armored bulldozer, cranes, graders, excavators, and M35-2 Monniaux 1/2-ton cargo truck. Militarized heavy equipment may also take on the form of traditional civilian equipment designed and built to unique military specifications. These vehicles typically sacrifice some depth of capability from civilian models in order to gain greater speed and independence from prime movers. Examples of this type of vehicle include high-speed backhoes such as the Australian Army's High Mobility Engineering Vehicle from Thales of the Canadian Army's Multi-Purpose Engineer Vehicle from AVA. The main article for civilian heavy equipment is heavy equipment, armored engineering vehicle typically based on the platform of a main battle tank. These vehicles go by different names depending upon the country of use or manufacture. In the US the term combat engineer vehicle is used. In the UK the term armored vehicle Royal Engineers is used, while in Canada and other Commonwealth nations the term armored engineer vehicle is used. There is no set template for what such a vehicle will look like, yet likely features include a large dozer blade or mine plows, a large caliber demolition cannon, augers, winches, excavate arms and cranes or lifting booms. These vehicles are designed to directly conduct obstacle breaching operations and to conduct other earth-moving and engineering work on the battlefield. Good examples of this type of vehicle include the UK Trojan AVRE, the Russian IMR, and the US M728 combat engineer vehicle. It should be noted that while the term armored engineer vehicle is used specifically to describe these multi-purpose tank-based engineering vehicles, the term is also used more generically in British and Commonwealth militaries to describe all heavy tank-based engineering vehicles used in the support of mechanized forces. Thus, armored engineer vehicle, used generically, would refer to AEV, AVLB, assault breachers, and so on. Armored earth mover, lighter and less multifunctional than the CEVs or AEVs described above. These vehicles are designed to conduct earth-moving work on the battlefield. These vehicles have greater high-speed mobility than traditional heavy equipment and are protected against the effects of blast and fragmentation. Good examples are the American M9 Ace and the UK FV-180 combat engineer tractor breaching vehicle. These vehicles are equipped with mechanical or other means for the breaching of man-made obstacles. Common types of breaching vehicles include mechanical flails, mine plow vehicles, and mine roller vehicles. In some cases, these vehicles will also mount mine clearing lines and charges. Breaching vehicles may be either converted armored fighting vehicles or purpose-built vehicles. In larger militaries, converted AFV are likely to be used as assault breaches while the breached obstacle is still covered by enemy observation and fire, and then purpose-built breaching vehicles will create additional lanes for following forces. Good examples of breaching vehicles include the US MCM-1 assault breacher vehicle, the UK Aardvark JSFU, and the Singaporean Trailblazer. Bridging vehicles. Several types of military bridging vehicles have been developed. An armored vehicle-launched bridge is typically a modified tank hull converted to carry a bridge into battle in order to support crossing ditches, small waterways, or other gap obstacles. Another type of bridging vehicle is the truck-launched bridge. The Soviet TMM bridging truck could carry and launch a 10-meter bridge that could be daisy-chained with other TMM bridges to cross larger obstacles. More recent developments have seen the conversion of AVLB and truck-launched bridge with launching systems that can be mounted on either tank or truck for bridges that are capable of supporting heavy main battle tanks. Earlier examples of bridging vehicles include a type in which a converted tank hull is the bridge. On these vehicles, the hull deck comprises the main portion of the treadway while ramps extend from the front and rear of the vehicle to allow other vehicles to climb over the bridging vehicle and cross obstacles. An example of this type of armored bridging vehicle was the Churchill Ark used in the Second World War. Combat engineer section carriers. Another type of CEVs are armored fighting vehicles which are used to transport sappers and can be fitted with a bulldozer's blade and other mine-breaching devices. They are often used as APCs because of the carrying ability and heavy protection. They are usually armed with machine guns and grenade launchers and usually tracked to provide enough tractive force to push blades and rakes. Some examples of the US M113 APC IDF Puma, Nagmachon, Husky, and US M1132 ESV. Military ferries and amphibious crossing vehicles. One of the major tasks of military engineering is crossing major rivers. Several military engineering vehicles have been developed in various nations to achieve this task. One of the more common types is the amphibious ferry, such as the M3 amphibious rig. These vehicles are self-propelled on land. They can transform into raft-type ferries when in the water, and often multiple vehicles can connect to form larger rafts or floating bridges. Other types of military ferries, such as the Soviet Plavyushij Transport or SREDNYJ, are able to load while still on land and transport other vehicles cross-country and over water. In addition to amphibious crossing vehicles, military engineers may also employ several types of boats. Military assault boats are small boats propelled by oars or an outboard motor and used to ferry dismounted infantry across water. Tank-based combat engineering vehicles. Most CEVs are armored fighting vehicles that may be based on a tank chassis and have special attachments in order to breach obstacles. Such attachments may include dozer blades, mine rollers, cranes, etc. An example of an engineering vehicle of this kind is a bridge-laying tank, which replaces the turret with a segmented hydraulic bridge. The Hobart's funnies of the Second World War were a wide variety of armored vehicles for combat engineering tasks. They were allocated to the initial beachhead assaults by the British and Commonwealth forces in the D-Day landings. Churchill tank. The British Churchill tank, because of its good cross-country performance and capacious interior with side hatches, became the most adapted with modifications, the base unit being the AVRE carrying the large demolition gun. M4 Sherman Dozer. The bulldozer blade was a valuable battlefield tool on the World War II M4 Sherman tank. A 1943 field modification added the hydraulic dozer blade from a Caterpillar D8 to a Sherman. The later M1 dozer blade was standardized to fit any Sherman with VVSS suspension, and the M1A1 would fit the wider HVSS. Some M4s made for the engineer corps had the blades fitted permanently and the turrets removed. In the early stages of the 1944 Battle of Normandy, before the Cullen Cutter, breaking through the bocage hedgerows relied heavily on Sherman dozers. M4 Dozit Engineer Corps Sherman dozer with demolition charge on wooden platform and T-40 whiz-bang rocket launcher. Bridge layer. The U.S. field converted a few M4 in Italy with A-frame supported bridge and heavy rear counterweight to make the mobile assault bridge. British developments for Shermans included the Fasten, Crib, Twaby Arc, Octopus, Plymouth, and Davy RE. Mine clearing. British conversions included the Sherman Crab. The U.S. developed an extensive array of experimental types. T-15, E-1, E-2, series of mine-resistant Shermans based on the T-14 kit. Cancelled at war's end. Mine exploder T-1 E-1 roller. 3 sets of 6 discs made from armor plate. Mine exploder T-1 E-2 roller. 2 forward units with 7 discs only. Experimental. Mine exploder T-1 E-3 M1 roller. 2 forward units with 5 10-feet discs. Most widely used T-1 variant, adopted as the M1. Mine exploder T-1 E-4 roller. 16 discs. Mine exploder T-1 E-5 roller. T-1 E-3 M1 with smaller wheels. Experimental. Mine exploder T-1 E-6 roller. T-1 E-3 M1 with serrated edge discs. Experimental. Mine exploder T-2 flail. British Crab Eye mine flail. Mine exploder T-3 flail, based on British Scorpion flail. Development stopped in 1943. Mine exploder T-3 E-1 flail, T-3 with longer arms and sand-filled rotor, cancelled. Mine exploder T-3 E-2 flail, E-1 variant, rotor replaced with steel drum of larger diameter. Development terminated at war's end. Mine exploder T-4, British Crab 2 mine flail. Mine exploder T-7, frame with small rollers with 2 discs each. Abandoned. Mine exploder T-8, steel plunges on a pivot frame designed to pound on the ground. Vehicle steering was adversely affected. Mine exploder T-9, 6-feet roller. Difficult to maneuver. Mine exploder T-9 E-1 lightened version, but proved unsatisfactory because it failed to explode all mines. Mine exploder T-10 remote control unit designed to be controlled by the following tank, cancelled. Mine exploder T-11 6 forward firing mortars to set off mines. Experimental. Mine exploder T-12 23 forward firing mortars. Apparently effective, but cancel. Mine exploder T-14, direct modification to a Sherman tank, upgraded belly armor and reinforced tracks, cancelled. Mine excavator T-4, plow device, developed during 1942, but abandoned. Mine excavator T-5, E-1, E-2, T-4 variant with V-shaped plow. E-1, E-2 was a further improvement. Mine excavator T-5 E-3, T-5 E-1, E-2 rigged to the hydraulic lift mechanism from the M1 dozer kit to control depth. Mine excavator T-6, based on the V-shape. T-5, unable to control depth. Mine excavator T-2, E-1, E-2, based on the T-4, T-5S, but rigged to the hydraulic lift mechanism from the M1 dozer kit to control depth. M60 M60A1 AVLB Armored Vehicle Launched Bridge 60-foot scissors bridge on M60A1 chassis. M60 AVLM Armored Vehicle Launched MICLIC Modified M60 AVLB with up to 2 MICLIC mounted over the rear of the vehicle. M60 Panther M60 modified into a remotely controlled mine-clearing tank. The turret is removed with the turret ring sealed, and the front of the vehicle is fitted with mine rollers. M728 CEV M60A1 based combat engineer vehicle fitted with a folding A-frame crane and winch attached to the front of the turret, and an M135 165mm demolition gun, commonly fitted with the D7 bulldozer blade, or a mine-clearing equipment. M728A1 upgraded version of the M728 CEV. M1 Grizzly Combat Mobility Vehicle. M1 Panther 2 Remote-Controlled Mine-Clearing Vehicle. M104 Wolverine Heavy Assault Bridge. M1 Assault Breacher Vehicle. Leopard 1 Biber Armored Vehicle Launched Bridge. Pioneer Panzer 1, Pioneer Panzer 2 Dax Armored Engineer Vehicle. Leopard 2 Panzerschnellbrücke 2, Pioneer Panzer 3 Kodiak, T-55 54th T-54 Dozer, T-54 fitted with bulldozer blades for clearing soil, obstacles and snow. Alt 55 bulldozer version of the T-55 with large flat plate superstructure, angular concave dozer blade on front and prominent hydraulic rams for dozer blade. T-55 hull fitted with an excavator body and armored cab. T-55 Mars fitted with a Vickers armored recovery vehicle kit. It has a large flat plate turret with slightly chamfered sides, vertical rear and very chamfered front, and a large A-frame crane on the front of the turret. A crane has cylindrical winch rope fear between legs of crane. A dozer blade is fitted to the hull front. Mount 55 or MTU-55 Soviet designator for Czechoslovakian MT-55A bridge layer tank with scissors bridge. MTU-12 bridge layer tank with 12 meters single-span bridge that can carry 50 tons. The system entered service in 1955. Today only a very small number remains in service. Combat weight 34 tons. MTU-20. The MTU-20 consists of a twin treadway superstructure mounted on a modified T-54 tank chassis. Each treadway is made up of a box-type aluminum girder with a folding ramp attached to both ends to save space in the travel position. Because of that, the vehicle with the bridge on board is only 11.6 meters long, but the overall span length is 20 meters. This is an increase of about 62% over that of the older MTU-1. The bridge is launched by the cantilever method. First, the ramps are lowered and fully extended before the treadways are forward, with the full load of the bridge resting on the forward support plate during launch. The span is moved out over the launching girder until the far end reaches the far bank. Next, the near end is lowered onto the near bank. This method of launching gives the bridge layer a low silhouette, which makes it less vulnerable to detection and destruction. MTU-20 based on the T-55 chassis. BTS-1. This is basically a turretless T-54A with a stowage basket. BTS-1M improved a remanufactured BTS-1. BTS-2. BTS-1 upgraded with a hoist and a small folding crane with a capacity of 3,000 kg. It was developed on the T-54 hull in 1951. Series production started in 1955. The prototype OP-9 had a commander's cupola with DSHK 1938 46th machine gun, but the production model has a square commander's hatch, opening to the right. Combat weight 32 tons. Only a very small number remains in service. BTS-3JV BT-55A in service with the Soviet Army. BTS-4 similar to BTS-2 but with snorkel. In the West generally known as T-54T. There are many different models based on the T-44, T-54, T-55 and T-62. BTS-4B Dozer blade-equipped armored recovery vehicle converted from the early odd-shaped turret versions of the T-54. BTS-4BM experimental version of the BTS-4B with the capacity to winch over the front of the vehicle. IMR combat engineer vehicle. It's a T-55 that had its turret replaced with a hydraulically operated 2T crane. The crane can also be fitted with a small bucket or a pair of pincer-type grabs for removing trees and other obstacles. A hydraulically operated dozer blade mounts to the front of the hull. It can be used in a straight V configuration only. The IMR was developed in 1969 and entered service 5 years later. SPK-12G heavy crane mounted on T-55 chassis. Only 2 were built. BMR-2 mine-clearing tank based on T-55 chassis. This vehicle has no turret but a fixed superstructure, armed with an NSVT machine gun. It is fitted with a KMT-7 mine-clearing set and entered service around 1987 during the war in Afghanistan. Improved version of BMR-2 that has been seen fitted with a wide variety of mine roller designs. T-64 Bat-2 fast combat engineering vehicle with the engine, lower hull and small road wheels. Suspension of the T-64. The 40-ton tractor sports a very large, all-axis adjustable V-shaped hydraulic dozer blade at the front, a single soil ripper spike at the rear and a 2-ton crane on the top. A crew compartment holds 8 persons. The highly capable Bat-2 was designed to replace the old T-54, a T-based Bat-M, but Warsaw Pact allies received only small numbers due to its high price and the old and new vehicles served alongside during R. T-72 IMR-2 combat engineering vehicle. It has a telescoping crane arm which can lift between 5 and 11 metric tons and utilizes a pincers for uprooting trees. Pivoted at the front of the vehicle is a dozer blade that can be used in a V configuration or as a straight dozer blade. When not required, it is raised clear of the ground. On the vehicle's rear, a mine-clearing system is mounted. IMR-2M1 simplified model without the mine-clearing system. Entered service in 1987. IMR-2M2 improved version that is better suited for operations in dangerous situations, for example in contaminated areas. It entered service in 1990 and has a modified crane arm with bucket instead of the pincers. IMR-2MA latest version with bigger operator's cabin armed with a 12.7 mm machine gun NSV. KLIN-1 remote-controlled IMR-2, MTU-72 bridge layer based on T-72 chassis. The overall layout and operating method of the system are similar to those of the MTU-20 and MTU bridge layers. The bridge, when laid, has an overall length of 20 meters. The bridge has a maximum capacity of 50,000 kilograms, is 3.3 meters wide, and can span a gap of 18 meters. By itself, the bridge weighs 6,400 kg. The time required to lay the bridge is 3 minutes, and 8 minutes for retrieval. BLP-72 The East German Army had plans to develop a new bridge layer tank that should have been ready for series production from 1987, but after several difficulties the project was cancelled.